No, there was one other idea. I'm going to be using potentiometers to measure the amount that each DC motor has turned in order to send feedback to the computer, indicating whether that motor is successfully turning or just burning up electricity and not moving. So that will aid me in collision detection with the robot. So let's say he's trying to move his finger like this, but a table ledge is in the way and it's not moving. Well, he would then know, hey, it's not moving. Or it's moving slower than we thought. So that could indicate something's wrong, or he's lifting something with that finger, maybe a book's on top of it. So it'd just be more information about what's happening. We can't just assume... Oh, and since we won't know how fast things are moving, we can't just tell the motor to turn for X amount of time and it tries to turn, it doesn't move at all, and the computer thinks it moved the limb. What if the limb didn't move at all? So the computer needs feedback that, hey, nothing happened, you need to keep trying to move that motor. Or you need to activate additional motors to give it even more strength to that muscle because it's not getting enough strength to move that limb. And in order to connect the potentiometers, I was thinking of coating the muscle wire with like rubber, and then the potentiometer could be pressed against it with some force, and as the wire's moving, the potentiometer would turn, which would change its resistance reading, which the computer could read in order to determine the amount that the potentiometer has turned, and then it could calculate how much the DC motor has pulled or released the string. So it'd be a friction-based actuation of the turning of the head of the potentiometer. That's what I've come up with so far. And hopefully that will work. We'll have to experiment a lot with that. Either that or connect the potentiometer directly to the bone, and then as the bone's pulling, it would turn it somehow. It's tricky stuff. But that's important, super important for the feedback. Otherwise the robot doesn't know where his body is. It doesn't know if its arm is straight or extended, if its fingers are in a fist or open. It shouldn't have to look at it to tell through computer vision. It should be able to feel whether its fingers have opened or closed. It should feel it. And it's going to feel, quote unquote, by the potentiometers. That's how it's going to feel where its body is. And then it will be able to make decisions based on that. Feedback is critical.